pressure.
No pressure. Well, hello everybody, and good afternoon. Welcome to our webinar on energy efficiency programs for Wisconsin power customers, and this is in coordination with our friends at Focus on Energy, and wanted to welcome you. Today, we will be having Brad Taylor, our sales engineering manager, Mel Omar, our sales engineering guru in Franklin, Wisconsin at our location there. My name is Michael Heine. I'm the Director of Marketing for Fluid-Aire Dynamics. And we've got Laura Tenpenny with us, an energy engineer with Focus on Energy. So just wanted to introduce these folks, have them say a few words about their specialty and areas of focus. And we'll start with Laura. And so Laura, tell us a little bit about Focus on Energy and your role there.
Hi, well, I'm Laura Tenpenny. I am with the Focus on Energy industrial group. I'm the team lead, and we have about 5 other advisors who are across the state. So up in Green Bay, Eau Claire, Madison, Milwaukee area. So we do cover the entire state of Wisconsin. Focus on Energy is a state energy efficiency program, which is with participating utilities, which is how the program is funded. So customers who are with utilities that participate with us are able to get financial incentives to help offset the cost to go to more energy efficient options, whether it's lighting, compressed air, HVAC, pretty much any way you can save energy, we want to try to help make that affordable.
Fantastic, thanks Laura.
Mm-hmm.
And Mel Omar, been in the industry for decades. Why don't you tell our audience a little bit about yourself?
It sure seems like it. No, I've been in the business since 1977. The business has changed quite a bit. The industry has. Back 30 years ago, you just made sure you had a big enough compressor for the customer and you didn't have any problems. Well, now things are a lot more refined, and one of our biggest goals is working with the customer and Focus on Energy on developing and supplying a system that is most energy efficient and reliable for their needs. So we look into many things in their facilities as to how they're using air and how much air they're using, and then try to come up with a good solution for them. So it's been an interesting few years, and with Focus on Energy help, it helps push some people over the edge on certain projects. So thank you.
Excellent. Thanks, Mel. And Brad Taylor, one of the owners of our company based in Schaumburg, Illinois. Brad, say a few words, and then we'll go ahead and get started with the first slide.
Okay, very good. Well, since I wasn't born until 1979, Mel's got a couple years on me. But the joke in the industry here is that I've been doing this since I've been in diapers. So I hope to share some of that with everyone on the call here today. So the main focus of our presentation today is to share some insights, tips, what's available from our friends over at Focus on Energy. And so I'm going to be relying heavily on Mel and Laura to get me through these slides, but I think they're very valuable in sharing what you could potentially do with your system and how you guys could save energy, especially in these crisis times we're hopefully getting through quickly. So Focus on splits their system or their incentives into 2 programs. Your prescriptive, which is essentially X number of dollars for the incentive for X number of quantity of horsepower or installed products such as drain valves. And then, of course, the custom side. So just to go through some of the points of what's included for a prescriptive, or what you need to do to qualify, there are certain qualifications that you have to go through. There is not a pre-approval process. In fact, you can even install the equipment and submit an application after that installation has been complete. I think one of the benefits of working with Fluid-Aire is it takes out some of the unknown through our sales process or quoting process, in that we provide the incentive dollars in the proposal, meaning that we or Focus On would pay us once the project is completed, making it an instant rebate to you and eliminates that unknown. And a more obvious point might be that the customer must be a Focus On customer as well. And you could log onto the website you see there to verify those points. Next slide, please. The custom program is a little different in the sense that it does require a pre-approval process. There's certain documentation that has to be submitted to be pre-approved for the project before we can proceed. The nice thing about the custom incentives is that you can rope in about anything that delivers energy savings into this type of an application. And they will pay up to 50% of the cost of our investigative phase, whether it's data logging or walkthroughs or whatever it may be. Next slide, please. So when we're talking about prescriptive, and Laura will help me out here, the most obvious is variable speed type compressors. It's a flat rate of $40 per horsepower, and it must be replacing a fixed speed type compressor or non-variable speed. But it can also be used in new installations as well. System must not previously have variable speed drive installed, meaning if you have one already and it failed, this type of incentive does not cover replacement of existing variable speed drive compressors. And then so that they're seeing the return on the investments that they're investing for energy savings, there must be a minimum of 2,000 hours runtime annually, or at least a single shift of operation. There's no limit on horsepower of the incentive, and it does require the replacement of piston compressors, which is a really great feature. Air compressors purchased or installed for backup or redundant systems do not qualify. Next slide. And then just to continue on, the equipment being replaced must be removed unless it's used for backup. Again, we don't want to be spending investing dollars, incentive dollars in a project only to have the lesser efficient compressor running as primary. So there's a little bit of setup in the controls so that we have the more efficient compressor be the primary. We limit 1 VFD per system, and compressor system with large load variations requiring multiple VFD trim compressors may qualify for a custom incentive. Laura, is there anything you can add to that?
No, I mean, that's pretty much it. If you have a non-variable speed and you're looking to go to one, we do have the incentive, which is a nice straight dollar per horsepower. And if it doesn't quite meet the application, like you were saying there, that last bullet point, if you have a special system that does require you to have multiple VSD compressors, we can look at that on a custom basis. The way that prescriptive measures work is it's meant to be easier for the customer. So we have certain guidelines to start for us to estimate our energy savings, which is how we came up with the flat incentive. If it kind of falls out of that range, we need to take a deeper look into it and go custom.
That's good. So we'll talk about this a bit later on, but typically what we do as a courtesy service for our clients is just a 1 week minimum data logging. It gives us a snapshot of what your system looks like, and will help us understand what type of compressor should be used, fixed speed, type of fixed speed, or size of fixed speed versus size of variable speed drive, or in some cases where the demand widely changes, it does make sense to use multiple variable speed drives. So that's a good point. All right, next slide. So this begs the question, many of the providers or incentives in the markets we serve have very generous offerings towards variable speed drive compressors. So it begs the question, what are the advantages of variable speed drive? what is the benefit? What's it going to do for me besides just getting me an incentive? And I suppose many of you on this call today are familiar with what this box looks like. It's a little box in the corner that makes some noise, creates a ton of heat, consumes a lot of energy, and makes your operations go. Next slide there. The guts of it look similar to this, like a blower on top of a race car. They're more efficient than a piston machine, relatively quiet unless it's super old. It can be a screamer, and in most cases will deliver a lower oil carryover when compared to a piston type compressor. So if we go to the next slide, this will show us, in essence, we're adding a variable speed drive to a fixed speed compressor. Now, of course, it increases the capital cost of the equipment, but there are a lot of other benefits that come with varying the speed of a fixed speed type compressor. Next slide there.
Say, Brad, if I could just add a couple of points to that, that are on there. Is the variable speed compressor, in most cases, customers are looking at energy savings as definitely as the biggest benefit. But with a lot of that, with slower speeds, you have less noise, you have more durability with some of the components and things like that. So, you know, it's a good, it makes it into a more reliable and dependable machine also. So it's just a good situation where you're using only the horsepower you need to get your work done out in your plant. So I just wanted to add that in.
Yeah, exactly. And I think those points you just covered off on are here on this slide. I think another big one that I'm sure you're aware of is the reduced amount of heat load in the plant. So what happens, Mel, and feel free to chip in at any time, is with a fixed speed type compressor, there's essentially two modes of operation: fixed speed load and load, or fixed speed modulation. With a load and load type compressor, we don't just turn them on and off like we do with a piston machine. We turn them on and then it loads and unloads using an inlet valve controlled by a solenoid that varies the pressure. So as we get up to set pressure A, we then consume air and it drops down to the lower set pressure and reloads. Well, during that period of time that the machine is running unloaded, it's essentially sitting there spinning, doing absolutely no work. And that's the wasted energy that you're referring to, is being able to vary the speed to match the demand. And those other advantages just naturally come along with it, such as reduced wear, reduced maintenance, reduced noise, reduced heat, all those things you were just discussing. So great point. The other advantages, though, like with modulation, is you get a steady pressure output. And what we've had some customers tell us is that it gives a better product output, because that press that's used as compressed air, or whether it's screen printing or moving product out of a die, when it has a steady flow or a steady pressure of compressed air, they get a better quality output, or they could run their processes at a faster speed. Is there anything you could add to that, Mel?
Yeah, it goes back to one of your rule of thumbs you mentioned earlier. How about if we can reduce the system pressure by 2 psi, we'll save 1% in energy. And I think Laura and everybody else uses that rule of thumb. And what it is if you can set your compressor to run at 100 pounds, and that's where your equipment runs efficiently, you don't need to go up to that 120 pounds. So that's how variable speed is going to save you money right off the bat, is because you don't have that pressure band. If you want 100 pounds or you want 95 pounds, that's what you get, and anybody in the industry will tell you the lower you can keep your system pressure, the better. It's just more efficient and it's easier on your equipment. So
if you go to the next slide, Mike, this shows the different control modes, and we talked very briefly about load unload compressors and why this is so important, talking about energy and maybe not so much about the color of the compressor or the brands. While that's of course important, 80% of the cost of our compressors after they're installed is the energy to run them. So it makes sense to talk about energy. So what Mel was just discussing there is about the constant pressure and the better output. Is back many decades ago, they solved this pressure swing issue with modulation control. And I don't know if they knew what they were doing at the time, or maybe energy was free back then, but they created a scenario where in the lower demand ranges, it was consuming a lot more compressed air or a lot more energy than if they were running at load unload. So above 20 or above 80% load on a compressed air system, modulation can actually be the more efficient mode to run a compressor, because we don't have the sump blowdowns, sump unloads that we have to recompress or use energy to get back up to line pressure again. Below 80%, especially when we get down below 50%, what happens is the intake throttles off to a point that the inlet pressure drops. And when compared to the outlet pressure, the compression ratio starts to expand greatly. And that takes a lot more energy to compress air from what used to be an 8-to-1 compression ratio up to something that's 30 or 40 to 1. So the better way to do this, to get the benefit of both worlds, is to use variable speed drive technology and to match the input kW to the output supplied to your production. And that's what you see there in that dotted line. They make it look nearly 1-to-1. There is a bit of a curve to it, but for the sake of this presentation, that's the line that it tends to trend. Anything on this, Laura? Or, go on, Mel.
Well, Brad, from your chart, I think most people can see with your percentage of output at, let's say, 20%, you go up to the purple line with the modulation, you see how much power savings there is. And if you go from the green dotted line, which is your variable speed, to the purple, there's huge amounts, especially at low demands. And this becomes a real big issue with facilities that maybe have a scaled down second or third shift, things like that, where maybe the compressor sized pretty well on first shift, but you get into second, third shift, and it's really just pulling a lot of power for you. So we go into every new customer by taking a look and data logging with them and seeing where we could save energy, because as people look at it, we all have to charge something for our equipment, but if we can save energy and be a good partner for you, that's what we're looking for. So.
Anything you'd like to add, Laura?
No, I think that was a great point. It's not uncommon for a lot of equipment to not be the right size for every single moment, and you have to have it sized, for that busiest time of the day to have the available air. But like you said, different shifts, or even within the same shift, you may have different periods of time where you're not really consuming full or near full capacity of where that equipment would normally operate at its most efficient. So most of the time you're at that part load, and if you can match that by using a variable speed compressor, you have the ability to save a lot of energy.
Even take the COVID crisis. We don't know how long this is going to go on, and we don't know how long it's going to change or affect our production cycles. Hopefully it'll go back to normal, but it might make sense during these periods to be doing data logging and reviewing whether our demands are fluctuating to meet outputs. So,
yeah, I think data logging is a great way to really tell what is needed, because your facility may change, and at one point you need so many horsepower of compressed air, but you add equipment and then you take some out, and you just think, oh, I'll just add more. More is better, but more is not as efficient. So you want to make sure you're really matched with what you need, and that's where I think data logging is a great way to find exactly what it is.
Oh, that's good. All right, so moving on, another incentive is leak detection and repair. Department of Energy tells us, and we have proven, that the average system consumes or uses about 35% of their compressed air towards or to feed leakage. We've seen it as, in some cases, as high as 70%. That example was in the winter months when the customer had some large bag houses outside and pulse valves froze or had a cracked diaphragm and they were stuck open and nobody wanted to go out in the cold. So there you have a valve that's consuming upwards of 200 CFM of compressed air and nobody knew about it. This is types of things that continuous monitoring would cover, or through continuous leak detection programs within your company. So Focus On has offered an incentive of $4 per running horsepower. So this is does not include backup compressors in that number. The incentive is eligible for up to 100% of the survey and repair costs with a maximum incentive of $4,000 per year. Leaks must be repaired before submitting an application, and you must repair at least one leak for every 5 horsepower. Otherwise, they will restrict how much they pay out. And some exceptions may apply for leaks that cannot be repaired due to special circumstances, such as a large cylinder inside of a production machine that can't be shut down, or maybe that cylinder cup seal is not available anymore. But I appreciate it if you could expand on this a bit more, Laura.
Yeah. So the point of the incentive is to help get customers get in someone to do an ultrasonic leak detection. A lot of facilities may do their own leak repair. They listen when they're shut down and they try to do the best they can to find those. But there's quite a few leaks that are inaudible to our ears, especially if the plant is up and running. Like you were saying, in some of those machines, you may shut down, you won't hear leaks because the machine isn't up and running. It's not having the air supplied to it for, in that situation. So having someone come out and use the ultrasonic detector to find those leaks, the point of the incentive is to help with that barrier to get someone out there and pay for that cost. And as I'm sure you'll talk later, the costs that the leaks themselves are wasting in energy throughout the year are very quick payback. So when you do find them and you make the repairs, it's a very good investment.
If you go to the next slide, Mike. So just to continue on, then we're going to talk a little bit about what you just touched on, Laura, about the cost of leaks. Each leak must have a leak tag for at least 4 months. We, or your current compressed air provider, is responsible for the verification of the leaks. And you guys can do these surveys every 12 months per site. A leak log must be submitted, which we do through an Excel sheet. And there's certain data that you see that has to be recorded on each tag.
Yep, so I want to just jump in. The reason for leaving the tags in place for a few months after is in case you get pulled for a post-inspection. So with our program, we do have to verify. In some cases, we do random post-inspections where we'll pull applications. So that's where that's important too, is you don't want to take those tags off if you were to get pulled for a post-inspection and we're not able to verify that. It could result in issues with getting the incentive, but just wanted to throw that out there.
Okay, very good. All right, so this goes a bit through the leak detection process, our process, if you will. So while $4 per horsepower may not seem a lot, let's talk about what it's costing you in energy to delay fixing those leaks. So remember that 35% number that we referred to the Department of Energy. A compressed air leak costs about $35 per CFM annually per shift. So multiply that times the number of shifts you have, or if you're 24/7, multiply that number by 4.2 times. And then multiply that times the number of, or the quantity in CFM of leaks that you think you have. There's some real easy ways to quantify those leaks, such as a lunchtime or break time or end of day see what the duty cycle is of your compressor when nothing's running, and then multiply that percentage number by the output of your compressor, and just multiply that times 35. And that, if you're a single shift operation, or times 35 times 2 if you're a 2-shift operation. Or you could take this formula that Mike has here up on the screen, plug in your kW of your compressor or your horsepower times 7.46 to get kW, your energy cost including the associated taxes, and then just multiply it down through the leak rate of 35%, the hours you operate, to come up with your energy rate. So the little bonus that Focus On gives you is nice, but consider what an internal leak repair program benefits your company in keeping your competitive edge by implementing an internal program like this. Anything you add on this, Mel?
Yeah, no, I think you'll see that a lot of the, progressive type companies will stay on the leak detection. They realize that it does save them bottom line dollars. And it also prevents them from needing to buy further equipment to generate compressed air. So we've had a number of companies that were surprised at what their leak rate was. And it's just a matter of repairing them and then staying with it. The leak repair is something that usually you want to do annually, but it is something that people should be doing in-house to watch and for leaks and report them to a maintenance department, because there are big dollars involved.
I wanted to add one comment on there too. If you have a lot of leaks, a lot of times, maybe you can speak on this. We see a lot of companies who have to raise their pressure to compensate for a lot of those leaks too. And you talked about that for every 2 PSI, you can save about 1% in energy of that compressed air that's being produced. So not only can you lower your system pressure to save on your air compressor consumption, but if you're at a lower pressure as well, the cost of those leaks are not as high as well. So if you can get your system tightened up and keep up with it, it can help on both sides of that.
That's an excellent point, Laura. It's a really good point. And it brings up the point too about making sure that each of your compressed air uses are regulated as well where possible. Again, the higher the pressure, the higher consumption of that leak. So great point. All right, very good. Mel, you want to talk about vacuum pumps? Maybe Laura could chip in.
Yeah. Focus Energy is now covering VSD vacuum pump with variable speed. It's something that they realized is getting a little more popular with manufacturing where people need vacuum in their facility. It's vacuum I found also with a lot of facilities is something that is very up and down. They may run vacuum for 30 minutes and then they stop. So things like that can really help by having a variable speed vacuum unit, and with varying demands too. So it's a good energy saver as far as it goes, as far as saving power. And it's something that Focus realizes that anytime energy savings is there's potential there, you want to help try to back that up. So but anyways, so they have the 2 programs, one at the 30 horsepower and down, and then 40 horsepower and up. But it's something that's been recently added. Did I cover everything, Laura? Or? Yeah.
And again, if you're ever having a system that doesn't quite meet this, we can look at them as a custom application. Mm-hmm. But it's very similar to your compressed air. If you've got, loads that are changing, it's not compressed air, it's a vacuum. But again, you don't need that motor running as high as it needs to if it's at part load.
Correct. Yep.
Very good.
That's good.
So similar to the compressed air, they need to meet the minimum running hours, and it can't be a redundant or a backup vacuum pump as well. So, all right, carrying on. So then just jumping into dryers. there's two different types of dryers. I'm sure most on the call are aware, desiccant or refrigerated type. What we're going to talk about is the refrigerated type, specifically the incentives towards cycling type. So up to 200 CFM, the most common type of dryer is a non-cycling or a hot gas bypass type dryer. Then above 200 CFM, typically we have either a cycling or variable speed drive type dryer. And the way these two types of energy saving technology work, specifically the cycling type, is it uses some type of a thermal mass, whether it's a sand or a glycol solution in a tank, or there's even technology out there that uses ice. So the idea or concept is that it operates much like your refrigerator or air conditioner at home, that once the temperature has been achieved in the thermal mass, that we can shut off the refrigeration, the refrigeration circuit to conserve energy. And then as that thermal mass warms up, we can bring that refrigeration circuit back online. Or there's variable speed drive type that, much like a compressor, maintains the cooling temperature of the refrigeration circuit by varying the speed of the refrigerant compressor. Very efficient, very effective, but also gives you the lowest possible dew point before allowing before a freeze up should happen within the heat exchanger. So the incentive is $50 per CFM, or sorry, 50 cents per CFM for cycling or variable speed drive technology. Is that right, Laura?
Yep. Yep. And I think you'll touch on the next slide. It's just going to be limited to the CFM of either the cycling refrigerated dryer or the CFM of the air compressor itself.
Okay, I gotcha.
So yeah, just go ahead, Brad. One other thing on the cycling versus non-cycling. You know, in the non-cycling, basically that refrigerant compressor is drawing pretty much its full kW the whole time it's running. It's just bypassing gas. So you have zero energy savings if you're using very little air or if you're running at full speed. And also with a cycling dryer or in variable speed, it adds the durability and longevity of that compressor that's in there. If it's not running at full demand, it's going to be easier on the components that are inside of there. So just like with compressors, air dryers, you're going to pick up some dependability and longevity with them as equipment goes.
And for those of you that leave your compressed air dryers on overnight when you're not running production, cycling is another way to add some shutdown or standby capability, being that it'll shut down for a majority of the time, being that there's no heat load on that dryer. So a great point, Mel.
Yeah.
All right, then rolling into desiccant dryers, for those of you that use them, you make up about 2 or 3% of compressed air users. Where you require it, you require it. You have to have that low dew point, whether that compressed air is going to the outdoors or whether it's being fed into a lab or through some type of a hydroscopic material. We got to get that dew point down. When we're talking about dryers, especially ones that are beneath 200 CFM, they're really dumb, for lack of better words. The controls are not, they're very simplistic in the way the dryer operates. You got 2 chambers full of an absorbent, and it goes through or is controlled by switching valves, which is obviously controlled by a timer. And that timer will just cycle those towers back and forth regardless of the dew point level of your compressed air. Now, desiccant dryers consume about 15% of your compressed air to regenerate those adsorbent beads. So that's reducing the capacity of your system, but it's also consuming a bundle of energy. So what you can do for dryers that do not have this type of capability installed, or if you're considering a desiccant dryer, you can add smart controls as an option to conserve your purge flow. And in very simplistic terms, it's adding a hydrometer to the output port of the dryer, which then interrupts the signal between the switching valves. So if we're down to a -40 or down to a -20, and that's sufficient for my operation, I can now shut down my purge cycles and allow it to go into a standby mode. So very simple in a sense, but Focus On is offering an incentive of $2 per CFM of dryer capacity. Laura, is this for retrofit and new, or just retrofit?
This should be, I believe, retrofit. I have my catalog here just to take a secondary look. I can get back to you. Oh, it's right here. I believe you can add them on the back end as well.
Okay, very good. So when you're considering 15% purge, if we go back and use that number of $35 per CFM that I was referring to earlier, take a 100 CFM system for round numbers, 15 CFM of that is just going to the purge system. Well, if I could drop that by 50%, multiply that 15 times $35, multiply it by 0.5, it computes out to a couple $1,000s a year. That's just a small system, okay? You can buy retrofit Dewpoint demand controllers for around $5,000. So it's very, very, very fast ROI when we're talking about these type of controls. Or if you're considering buying a new desiccant dryer, the add-on feature of that control is more than likely less than what I just mentioned. What can you add, Mel?
Yeah, I agree. That 15% number is a big number. And when you start multiplying it out by the CFM, we typically, you don't steer somebody into a desiccant dryer unless they really need that low of a dew point. If you're able to do that with a refrigerated dryer, that's a more economical way to go. But the payback is huge on it, you know, and it's something that even, you know, if you're purging less, your desiccant left will last longer, things like that. So it's something that, you know, it is better to just add it on when you put the equipment in. So.
Yeah, I agree. All right, just to touch briefly, again, like Mel just mentioned, you typically do this when you sell a new compressor package, but you certainly could add it or retrofit it at any time, especially your compressors, your wet tanks, your pre-filter or refrigerated air dryer is a zero loss type drain valve. I'm a big fan of the float style since they will adapt to the humidity that's in the air without any electricity or power requirements to make them operate. There are electronic zero loss drains that use a high and low sensor to eliminate any air waste. So that's the goal, and that's why it's incentivized, is to try and limit any compressed air from escaping during the draining process. And it also eliminates any splashing in your condensate bucket or pail or tank when you eliminate the compressed air portion from the drain valve. So it's $80 incentive per drain and must be used in systems with no load or variable speed type compressors or variable displacement or centrifugal. Anything else you can add to that, Laura?
No, just that it's very common to have those old timer drains, and those are just timed leaks, and we hate leaks. So if you can not waste any of that compressed air, it's just gonna save in the long run.
Yeah, well, you mentioned timer drain. At least that's better than the drain valve half cocked open. So
that is true. That is true.
But yeah, so they're paying about 25% of a good zero loss drain valve. So it's a good incentive, especially when you bundle it with a compressor installation or a leak repair. It's a no-brainer. So moving on, pressure flow controllers, not to be confused with a regulator, although this would cover regulators, Laura, or no?
I guess I'll leave the being technical to you. We do have limitations, like you're going to talk about the size, and I believe all the bullet points here cover what is required. So I guess I'll just put a plug in at the end of the presentation. There's a link to the website where you can find the catalogs. So all of our catalogs are located on our website as PDF versions. So if you're looking for a little bit more specific details on any of the offerings that we have prescriptively, it may go into more details in the catalog as well. And if it fits those qualifications, it'll qualify for an incentive.
Yeah, so I think the answer may be in our last point there. So the difference between flow controllers and regulators is flow controllers have a very low pressure drop across them. You usually have some type of a sensing, electronic sensing device with a motorized butterfly valve internal of them. So the pressure differential when wide open is less than 1/2 PSI. The reason that regulators are not incentivized is because there's a pressure drop that escalates very quickly across the curve as the flow through the regulator increases. And while that may sound like a good thing, the bad side to it is that regulators typically are installed and they're undersized. And what that drives customers to do is go crank up their compressor room pressure to compensate for that undersized regulator. So I'm sure that entered into the decision as to why you limit it to flow controllers, technically termed as flow controllers, and paying 8 cents per kW or per horsepower of installation. Any points on this, Mel?
Yeah, no, I think you explained that well, Brad. Usually the regulators are used at a point of use, and that's usually for a specific machine that maybe wants a different pressure than the rest of the system. But the flow regulator, the main regulators will not have that large pressure drop, so you're not having to build up excess pressure and drive up your line pressure just to compensate. So yeah, I can see where the reasoning goes with the drop-in regulators. So,
and I'm definitely not as technically savvy with the compressed air, but I think is it true that these pressure flow controls are more for the main entire system versus, like you were saying, some of the regulators are at specific points within the system?
Correct. Yeah, you got it. Yeah, the flow controllers are for the main airlines coming through, and the regulators are specific for machines generally. You generally don't put a regulator on a main line of a shop unless it's very small. And I think that's why you're talking about pressure flow regulators at 50 horsepower and above, because they're made for larger systems. So. Okay, then we're going into mist eliminators. Brad, are you going to cover that, or should I jump in?
He may have froze.
Uh-oh, he froze. All right, well, mist eliminators. Basically, mist eliminators are there. A big reason for it is you can filter your air properly and get any contaminants out without having a large pressure drop. Most filters, or mainline filters, will have 4 to 5, sometimes 6 PSI of pressure drop across the system. And any key in this energy savings is to try to keep your pressures as low as possible. And that's why you would put in mist eliminator in lieu of, let's say, just a coalescing filter. So they are offering $4 per horsepower to install the mist eliminators. They're looking at systems that are larger than 50 horsepower. Mist eliminators must have initial pressure drop of only 1 PSI or less. Existing for existing buildings, the mist eliminator filter must replace a standard coalescer. So the whole theory behind this is reduce pressure drop, and that's going to save you the energy in the long run. Mist eliminators are good practice to put in lieu of a standard coalescing filter. So, is there anything you want to add to that, Laura, or is that?
No, that pretty much covers it. If you lower the pressure drop, you don't have to have your pressure set as high to compensate. And again, that 2 psi for 1% on the compressor is how that's saved.
Yeah, that rule of thumb is a big one that opens a lot of ears when I go out into the field, and you probably see that also, Laura.
Yep.
Is that, you know, if you can reduce your system pressure by 20 pounds, you can almost guarantee them they're going to get close to a 10% reduction in their energy cost. And that's a big savings. And the way your companies are now with the virus and everything else going on, everybody's looking at your bottom line, and your electrical costs are a big part of that bottom line. So.
And I know we'll probably talk about it when we get to the heat recovery, but just the fact of how much of your energy put into your air compressor doesn't go to usable work in that compressed air, you know, you start back calculating that, and you start realizing how much energy that simple air compressor is actually using at your facility.
Yeah, they're not, we talk about efficiency, but air compressors in general are not very efficient with energy. So can we go to the next slide, Mike? Air nozzles. Okay, so they're offering $8 a nozzle, and this is going to some energy saving type of air nozzle. A lot of them are more efficient than others, and basically you can cut your CFM usage about in half with a good energy efficient air nozzle. So it's something that every company should look at. Basically, you just need enough air to get the job done, get the parts cleaned off, or whatever you're doing with it. So the only thing they say there is that you must operate a minimum of 2,000 hours annually, but most production shops will fit into that category.
Mm-hmm.
Anything else to add to that, Laura? Or are we pretty good?
Nope, I think that's pretty good.
All right, you want to go to the next slide, Mike? Heat recovery. Okay. This is a big one. Most of it is, I think that Focus Energy is looking at saving energy in general, whether it's gas, electricity, or whatever, and they realize that heat is a form of energy. So if you put in some dampers and ducting to control that heat, send it outside when it's not needed, keep it inside when you'd like to heat your building with it. It's something that people are amazed at how much air and how much heat is coming off of those compressors. We're working with a company right now that is looking at doing that. They're looking at moving to a new location, and they want to recover that heat. So when you get into huge systems, it's an even bigger project, and there's a lot more energy that can be saved. Most of this, a lot of this ends up going through some type of custom grant. From what I've seen, there are some prescriptive guidelines for it, but a lot of it you have to try to quantify how much heat or energy you're saving.
Yeah, and it will make a difference too. You know, are you in a shop where you have air conditioning, and you know you're going to be saving on that air conditioning side of it? Well, if you're dumping the heat outside in the summer and keeping it on the inside in the winter as well. So we do have that prescriptive route if it fits that. But again, if you have a specific situation where it doesn't, we can always look at things as a custom project. And we've done this on things other than just air compressors, you know, as well, if you're recovering heat off of a chiller or something like that too. So.
Right. Yeah. Excellent point there. It's another customer I'm working with that he'd be putting heat into an air conditioned space. So he's really driving up his air conditioning costs. So it's kind of shooting yourself in the foot when you don't do something with that heat recovery. So you want to go to the next slide, Mike? Okay. Compressed air load shifting. overdue benefits and savings. We're looking at $200 for horsepower, compressor horsepower shifted. Incentive covers the replacement of inappropriate, inefficient use, points of use for compressed air. That's quite common in smaller shops where they're trying to blow waste away. They're trying to use an air knife, let's say. That's a big waster. And a lot of that, if you can shift that over to a lower pressure blower or something, other type of process, you can save quite a bit of compressed air and also save quite a bit of energy in doing it. So it's common enough that Focus on Energy is acknowledging it, and they're offering some good incentives for that. That again, it's something that you go into a facility and you see how they're using their air and see if it's appropriate or not. And if you see inappropriate air usage, you make recommendations to save power, and Focus Energy will take a look at it to help fund that. So.
Yep, and so this is one that, even though it falls in our prescriptive catalog, it is one that you do need to get in touch with your advisor ahead of time. There's a reservation code. So it does require a bit of, quote, pre-approval in the sense to just verify, and we do have to calculate what the savings are going to be, but it is set at that $200 per horsepower reduced on the compressed air side. So it's kind of a crossover between a custom and a prescriptive, because it does require some of that pre-approval.
Yeah, sounds good. Next one, completely custom projects. Equipment and projects fit into any of the prescriptive programs but have a demonstrable energy savings benefit. They'll all be looked at, okay? Basically, if you can try to prove energy savings and put it on paper and it makes sense, Focus Energy will take a look at it. And the bottom line is that they're trying to save you power. It keeps them from having to build more power plants and just be more efficient as a company. So all custom projects, you gotta have pre-approval. It's a good idea to talk with one of the agents to see what your project looks like, and they can help you come up with the necessary documentation to prove energy savings. So they are looking for a little longer payback period of 1.5 to 10 years. So anything else on that, Laurel?
No, the biggest thing is just making sure to get in touch with us ahead of time. If they're working with you, you're very familiar with how our program works. But the biggest thing with custom projects is nothing can be purchased ahead of time. We want to make sure that we're helping you influence to make your decision. So we want to take a look at it ahead of time. Maybe we notice there's other options you can do. We need to quantify the savings and see what else you can do for your system. A lot of compressed air stuff may fall under that prescriptive, which is great. But if there are situations where they don't, that's where we're going to look at it, and we calculate the actual energy savings for you. And then we're going to look at what that payback is and what incentive you might be available for. If it's less than 1.5 years payback, the hope is that it's such a great project that you are just dying to do it. And then we do limit it on 10 years as well on the top end. So, and most of the time, if you're in a situation too, where you're looking between 2 different pieces of equipment, sometimes you look at that cost and you go, how could I ever make a 10-year payback? Well, realistically, the idea of Focus on Energy is, well, what is the baseline equipment now? What would be standard equipment? And then what's efficient? And looking at that cost difference. So you're, bad example, but if you're putting in a new light fixture, standard is fluorescent. It's going to be LED soon, but standard is fluorescent. Well, LED is the more efficient. We're going to help try to justify that cost barrier to buy that little bit more costly product, but you're getting something that's more energy efficient. So the same thing can apply in the compressed air world. What's standard? What is the more efficient option? And what are those savings going to be between the two?
Okay, sounds good. How are we doing for time, Mike?
We're doing fine on time, actually. We're just coming right in at the end here. We did lose Brad. They lost internet over in Schaumburg, so he couldn't get a hotspot or anything working. So he just asked us to carry it on in here.
All right, that sounds good. What do
So
we have
we
up
did
on?
have,
Okay, go
we
ahead.
just had a little segment here on data logging. If you want to maybe just walk through that, Mel,
Sure.
and then we can go ahead and close it off for today.
Yeah, data logging, I'm very big on it. I feel it's very important. It can give you a picture of what is happening at its system. And it can be, you can data log several points. You can measure flow, pressure, dew point, temperatures, amperage, voltage. And some of them are used to size a system. Some of them are used to troubleshoot a system. But whenever we get into a new customer and we're not familiar with what kind of demand they have and things like that, we always start out data logging them, because we come in there and we can see, is the system sized properly? Are they using the right type of compressor? Things like that. You know, are we matching it to their flow? Do they have different shifts that require different flows? Things like that. So whenever we come in and a sales call, we try to data log first off, because now we know what we're dealing with. So a lot of things come up on these data log reports. If you look at Monday on the chart, you'll see that that circled area, that's showing leakage. That's the compressor's probably started up 2 or 3 hours before the plant is up and running, and that's showing leakage. And you'll see the same thing on Tuesday and every day of the week there. And what's interesting is you go over to Saturday and you see that it's all leakage. They probably kept the data logger on, which we typically do, because it's a quick way to find out how high a leakage rate a customer has right off the bat. Without even getting an ultrasonic gun on it, you can see what kind of percentage you have. So, and then if we do a data logging, what we'll do is we'll generally do up a full report on it. It'll tell you what the horsepower of your machinery is, the models, the efficiency of it, the output. And generally, if it's depending upon the types of controls you have, whether it's modulation or online, offline, we can calculate an energy savings cost for that. And when you take a look at some of these, you'll see that we have several customers where it'll have a 1 or 2 year payback on it. If they're going from let's say a modulation system to a variable speed. So it's a business decision at that point what your return on investment is, and if Focus on Energy can help you make that decision. I was always told years ago that that's what Focus Energy was for, was to help people make good, sound decisions. If something is going to save power and save money, they were going to help fund it, to help push that over the fence. So
That is exactly the point of what we're here for.
yeah. You're not here to fund everything. You're trying to make it more attractive so that they take energy saving measures. So.
Yeah, and we know that a lot of times those first costs when you're looking at a piece of equipment, the life cycle cost is not always looked at, which if you do, a lot of times more energy efficient products are easier to justify, but a lot of times that's not how you get something approved in your facility. I need a new air compressor. Well, what's the cheapest? What's the bare minimum we can do? And that's not always the best way to look at it, because you need to look at that overall life cycle cost. So if we can help you justify getting that more energy efficient equipment ahead of time, you're just going to start saving that energy right off the bat.
Yeah, no, that's a good way to explain it. Sometimes you have to spend a little bit of money to save money to go with an equipment that's going to save you energy, and it pays you back. If it's a cycling dryer, variable speed compressor, or even zero loss drains, they all save you money. So you have to sometimes spend that money to save the money. So,
Absolutely.
Well, very good. Well, we have not received any questions from the audience. There is a question tab. We can pause just a moment for that in case anybody has a burning question.
Okay.
Otherwise, we will go ahead and finish this off, we've got this recorded and we'll share this with everybody in attendance and also the absentees that registered but did not attend. And we'll even share with Brad so he can see how good of a job we did without him. So we appreciate your attention and attendance today. And Laura, thank you so much for being part of this and helping us pull this all together. And Mel also, we appreciate you. And do you have any parting words? I think we've got, let's see. Yeah, we'll be sharing the links. I don't have it on this deck here, but we'll be sharing the links and the resources that have been mentioned in this presentation also. So from Fluid-Aire Dynamics and Focus on Energy, we wish you a very pleasant afternoon, and thank you for attending.
All right, thank you,
Thank you.
Mike. How did it go? You're offline now?